Kannan sir, who is none other than the chairman IEI TNSC, to deliver us.
Thank you, Gokul. Thank you so much. Respected Chief Guest, Professor R Elangovan, former ISRO scientist and core team member of GSLV MK. I heartily welcome you, sir, for giving us a beautiful lecture on the topic SLV to SSLV journey of ISRO. And really speaking, it's a very good topic for the aerospace people, those who are all here, our committee members and our council members, our aerospace committee member and our scientist, Gokul. Really, he has told me that we'll arrange for a lecture from the aerospace. I immediately told him, okay, fine, you just arrange it. And really, I welcome you, sir. For
thank you. Thank you.
Committee members. I hope all will enjoy. It is, of course, it is a new field for me. I am a waterman. I am a marine engineer. I know only the ship sailing on the sea. I don't know exactly how the rocket is made and all those things. So I'll be more knowledge. I will get some more knowledge on this rocket launching and about the rocket. And anyway, we are associated with our Sivadana Pillai. He used to tell us a lot of things about this because I am very happy to say that he is our batchmate from Tyagaraja Engineering College.
I see. Oh, great, sir.
Yeah. We were together, and you have said, no, Elangovan sir is Abdul Kalam. This thing. Mr. Abdul Kalam studied in St. Joseph College. Actually, I also studied in St. Joseph College 7-8 years afterward. I have seen his photograph in the St. Joseph College.
I see.
All very nice that all people have a little bit also known to me and joined. Thank you very much for giving us a beautiful lecture on this. Of course, now the satellite launch vehicle, I think it has started in the early 1970s. And now the small satellite launch vehicles have started, and now I think recently Gokul has informed me that they are going to launch 3 vehicles. I think it is February 10th or 12th, Gokul. It is on February 10th, I think. Gokul, I think they have launched new 3 satellites from the small.
Well, SSLV, PSLV, DSLV.
Yeah.
All the 3 is going to be this month. Yeah.
Okay, very nice, sir. Very nice. I think.
I welcome
all the committee members, all the participants, and all the students. Those who they will get a lot of inputs and knowledge in this aerospace because they are nowadays even the students are making some small rockets to satellites to go into that one. I think last time I went to MGR College, I saw a small satellite they have made. So very nice. Thank you, sir. Thank you so much. I will ask our Vijay Raja to introduce our guest speaker.
Correct, man. Correct, man.
Yeah. Thank you, sir. Thank you very much. First of all, I would like thanks to our chairman, TNSC, that is IE, Dr. Kannan sir, for his wonderful welcome address. And it is my privilege and great pleasure and very proud to introduce our Professor R Elangovan sir. I know him very well for the last more than 15 years because he has. I am working with him in the Mohammad Sadak Engineering College in 1995 to almost 10 years, more than 10 years. He is the main person and he is worked as a HOD, and I was worked with him as a lecturer during the initial time. That is in 1995 starting our career, and he was the HOD. Earlier he was 20 years, I think he may be more than 20 years experience in the ISRO. Then after that, he has retirement. He worked as a deputy general manager in main companies. That is, and moreover in the ISRO, he has a lot of portfolio. He is having the project core team of GSLV, and we has worked as a Deputy General Manager in the Genius team, Malaysia. Then after that, he has worked as a HOD around various places. I can say that if you go through the biodata means it will take a lot of time, and I would like to very shortly complete that one. And he is having a lot of experience in the aerospace and aeronautical field. Not only aeronautical aerospace field, he was the main person in the Microsoft system, that is E, but he worked as a HOD of computer science department also. There is a new things for, I would like to say that, because he has controlled aerospace department as well as the computer science department during that period 95 to 2000, this period. Then after that, he has worked as a various places as a professor and various capacity of the chief operator, the officer, then chief marketing engineer, and professor level itself in the various places, not various places, various countries. He has worked as a various countries in the professor level, and he has worked as a vice principal in the AGS colleges, and now he is working as a professor in the KCG college. I think he was a guru for everyone, for us also, in the knowledge of aerospace field. And moreover, he always, whenever we need support, means immediately, without any hesitation, immediately he will support. That is the main. We would like to say that, very happy to say that one. Anytime, any places, any point of view. That is, he's a structure man, aircraft structure man, and any aircraft structure related and vibration, as well as the aerospace and then aeronautical things. And moreover, he is having a lot of contact with his experience, and nowadays he is having very close support to the startup companies. Lot of startup youngsters. He is supporting the main youngsters. That is whatever Abdul Kalam has told, that always support as well as the educate the students level. Like that only, he is doing lot of companies as an advisor, as a director, then as a consultant, as a lot of portfolio is doing that one. Various companies. I can say that one or two company mainly, Home Space, then Akka Studio, the Canada, and then Pacific Giant Space Facility, Australia. So like that is having lot of contact, lot of consultancy program, and lot of advisor and a director also in the various companies. And apart from that one, he is, I think nowadays, and not nowadays, that during the, after Corona, always whenever we are using the online program, is the main source or main person roam around not only Tamil Nadu, India level, even abroad also, through the online, because easily you can reach through online. So now he is doing a lot of work, a lot of program, lot of webinar, seminar through online, and moreover offline also. I think he may visited n number of school and colleges for giving lecture or seminar, then mainly about that aerospace field. I think I hope the time permits, you can say that much more also, because he is having a lot of capacity. He is having this 25 years or 30 years in the aviation field, and moreover, he is a very good human being. And when I was working with him, and now also I am working with him, is even when he was working in the Mohammed Sadar College, he was a HOD, and I am as a lecturer. Right now we are taking as a HOD. He is our professor, and is always supporting and helping us and guiding us in various fields. With this, I would conclude that one. I think thanks to all the IEI members, and then our chairman and secretary, and all the participants. Over to our chairman.
Yes, sir. So thank you, sir. Thank you so much. So we would like to invite our Elangovan sir, who is industry persons, researcher, as well as an academician. And also now he is becoming a mentor for so many startups. So the session is over to you, sir. You can take up.
Okay, thank you. Thank you for all the good words. I am not that much great. I am always very simple. Just a follower of Kalam because I am also from Rameswaram. But in a very junior to him. I met him, I know him when during my high school days. I am following him from my high school. And I also from Trichy, Bishopville and National College, PSC. And MIT and IET MTech from Correct. This is a simple thing. 1979, I have a lot of 1979 I joined when the ISRO is launching SLV. And 1995, 97 I came out as a GSLV core team member. Then I went to Muscat and Sultanate of Oman and colleges and everything. So it is total 43 years out of 17 years in ISRO, 17 years in institution and 7 years in company management in Gulf country and Africa. Okay, that's a symbol. But during this Corona, I have given around some 270 webinars by sitting for the last 3 years. And when the physical mode comes, they are all meeting at least 80% of them I am visiting. So I visited almost all high schools, all high schools, colleges, institutions around Tamil Nadu. Okay, last week also I was in the BITS Blani. And I am heading some of the startup to launch satellite or design satellite and rockets. This is my current situation. Anyhow, we will see that SLV to SSLV. I thank Google and the society to give me the opportunity to give me a talk on the favorite subject, the missile vehicle, large vehicles. Because India is the only one country which developed a launch vehicle not from missiles. So it is for a peaceful purpose, because all other countries developed for war purpose and then developed into satellite launch vehicles. But here, India is the only country which developed a satellite launch vehicle, then went into the missile field. Okay. So with this SLV actually is called SLV3 because 4 or 7 models were decided during the SLV time, and Vikram Sarabhai selected the 3rd model, SLV3. Actually, SLV3 is a 4-stage liquid solid propellant completely. It is the exact replica of almost like our Scout. There was a vehicle called Scout in America. When all these people went to NASA, all these 5 people, we used to call Panjabandavas of ISRO, Kalam, R Elangovan, Dr. Ishwara Das, and H.J.S. Murthy. All the people went to NASA for training. Kalam and Ishwara Das in the mission control and everything. And R Elangovan was already there in America, in NASA. So at that time, a lot of the Scout work also going on. They have seen lot of design of Scout vehicle is there. Then coming back to India after the first sounding rocket in 1963, it is called Niki Apache, was given by America, and only the payload was integrated and we launched. After the success of the sounding rocket, suddenly Vikram Sarabhai one day that we'll go for a launch vehicle in 70s. He suggested that even nobody can believe we can launch a satellite launch vehicle. So in that case, like that, it will start. Yeah. So the Sarabhai, the application of advanced technology, as Vikram Sarabhai always used to say, is very different. We will be deeply rooted to the society. So all the program is connected to the society. For one example, nobody knows Second World War. At least 10%, only 10% of the population knows there is a war is going. But once the TV has come, now we know everything, even a street fight in our next village, you can see in the TV. At the time, even the World War was not known to many people because the society is not connected with the technology of TV. That's what he implemented in site experiment. This was our earlier. You can see Niki Apache. Sound Niki is a booster, Niki, and Apache is a booster, and payload is by S. That it is what it is the first rocket launch from ISRO in 1963. This is actually mistaken. Somebody told this is a first rocket. No, it is not Kalam. It is Mr. C.R. Satya, who worked as he is the first who joined under Kalam. He is now in Bangalore. Actually, he's not well, actually. Yeah, he's a composite head. He's the man who developed the composite of ISRO. He worked in data advanced methods for some time, and now he's not okay sick. So he's the first junior who joined with Dr. Kalam in 1963, 65, like that. This is Chellappa Nair. His name is Chellappa Nair, not Kalam. He is 1972. This photo is taken. Somebody mistakenly telling it is 1963. It is 1972 when the Indira Gandhi came for a launch. There was only one jeep that was taken already. So they left the payload. I mean, Satya and other people. So all the way 2 kilometers, he went by a cycle with the payload, no scope. So that was the real story. Many people used to refer 1963, not correct. It is now the heat shield of our GSL. You can see that. So this is a nose cone, the same thing. Whatever there in 2022 we have grown. So this is from SLV to GSLV is a big journey. And SSLV is a different class of vehicle. We cannot say it is an improvement of a GSLV. It is a one class of vehicle for the small satellite launching. It is to facilitate to the student society or the people who want to launch a small satellite. That way, different. It is not an advancement. It is a different class of the vehicle itself. SSLV. So to start, 1957 Soviet Union started, and only few countries in the world has a capacity to launch satellite by their own vehicle from their own side. That is more important. So there are all the 92 countries has launched the satellite, but only the 12 countries have the capacity to launch satellite. As one of them is India. So we can see that 1980s India is launched this 1980. Then at the same time, 1970 ESA, European Space Agency formed. So these are the last country joined is South Korea. So these are the countries which have the capacity to launch their own satellite launch with their own satellite. Other countries are launching through other countries, right? So this is a scenario in which we are unique in one of the very few countries who have the launching capacity. Thanks to, and in 2018, we are a lot of satellites are there. All the satellites are owned by mostly by America, and we stand very low. And we, you can see that our India almost others it will be. So the number of satellites doesn't matter, but it must be useful to society, and we have improved our technology is much more important. The way America is more is because of the SpaceX, the OneWeb series they are launching. Number is 1,000. They are too much. They are the leading number of satellite wise. But anyhow, the America also have we are launching satellite for America also. That also they have to agree. Right. India, the 15 countries, 342 satellites we have launched so far. 177 spacecraft missions, 77 launch missions, and 10 student satellite also, 10 re-entry missions. That means recovery, SRE missions. This is what ISRO stands now with the GSLV Mark 3. So this we can see that this is a top country in 2020. 57 to May 2020, we can take the statistics. It's a very good visual, but it is a running visual. But I freeze and take in what is in the 2020 May. So world is around some 9568 satellites are there. So it is full of satellite. So we have 1993 PSLV by SSLV in 2022. Right? Sets world. We have set the world record also by setting that. So the 50s here, there are actually our ex-chairman, Kasri Rangan used to divide ISRO's procedure career as four phases. Complete. One is initiation phase, experimental phase, operational phase, and expansion phase. Very correctly in his book. Actually, you can see that somebody was telling I am marine. You can see Valirayam's book. It is a space to see. Our Kannan was telling is marine. Actually, our Muthulayam has mastered the space as well as sea. So that way there. Okay, these are 1960 and 1970 initiation phase. Initiation phase was lot of mistake. The search was CH. You are in the middle. We used to tell about the search. Here only we started our research. Research start from search. So that 1960 research, now it is a museum here in Trivandrum. So our humble shots are from the sounding rockets only. Sounding rockets, you can easily see there will be, there's no tower. The launch pad will be set up along with the rocket. So you can see that always launch pad is together, not like not tower nowadays. But there are RH is Rohini, 200 in the diameter of the rocket motor in millimeter. So up to 560 it was there. This is a Rohini series of launch vehicle. This completely sounding rockets only. After the success only, we will go for this one. This is Baba Atomic, Baba and Vikram Sarabhai. They took a bold decision. We'll go for launch vehicle. Actually, all the launch manual, everything was taken by Baba Atomic and given to India. He only arranged all the manuals to India at the time, BSSC. At the time, actually, when it was started, it was a surprise to everybody. We have joined into this paper on the day when SLV is launched. Successfully, we launched in the space club. First rocket fired successfully in the center in the 18 months. So it is a Vikram Sarabhai who have mastered, but it is guided by Baba Atomic, who is a senior. Right? Even Kalam also used to tell it was amazing. India is never a set head on like SLV or the design board, and still Sarabhai thought it is possible. So because at the time there was a lot of restrictions were there, and we start from scratch, which we don't know. Even a small technology like that, as you can see in the movie of what is that movie? The Madhavan's movie, where Nambinarayan used to tell. So even we are not able to integrate science and technology, right? There are a lot of mistakes. One such a mistake was Kalam and everybody was launching on sounding rocket. It was every 4 hours, 4 launching rocket has to be launched, sounding rocket. Say they put some gunpowder, it's explosive powder, so that the sounding rocket will reach the atmosphere of around some 80 kilometers. It will explode and spread the elastic stick, so that we can trace the wind velocity, speed, and everything the path. But what happened is that, and at the day of launching, Nambinarayan able to read a paper that up to 80 kilometer gunpowder pressure, under low pressure, 80 kilometer above, gunpowder will not work. But we have set up everything as if to assume it will work there. 80 kilometer, the pressure will be down. It didn't work. Actually, this was correct. When they launched all the four didn't work. That Kalam, Nambinarayan, and other his boss, everybody knows that it's not going to work. Still they launched. So this was our learning process at the time. In the early SLV. SLV time only the scout was a guide. Actually, America want to sell scout to us. But Kalam and Vikram Sarabhai told we will decide. We will not buy vehicle. That is the indigenous and only help Kalam to come up. And it is not only Kalam, it is first stage was Mr. Gaurikar was in charge for the first stage. Second stage was group. Third stage, Dr. Muthanayagam. Fourth stage only Kalam, and he is a project manager in shape. Okay, after that only it is completely credit goes to Kalam. So we have now set large market, we established. At the same time, when our Indian team was in NASA, there was a parallel Pakistani team also was in NASA. They also was trained by America. America is not exclusively for India. They have trained as well as Pakistani people also. They have seen around Rai road. That he has seen a lot of 6 or 7, 8 Pakistan engineers also, like Indian engineers were in training, but they couldn't make it. So it's only put 3 satellites, but we have done a lot. Right. This is what the SLV. SLV is a main problem. It is a Dr. Werner van Braun. You must be knowing. He is a Apollo. He is a Saturn director. Who is a German, went to America and launched this one. He came to India in 70s when the SLV was under construction. Kalam went to Chennai. From Chennai to flight, they came to Trivandrum. They were discussing a lot of things. After seeing the SLV thing, Dr. Werner van Braun told it will fail in aeroelasticity because of the large L by D. D is only 1, L is worth around some 20-70 meter. He had told it will fail in aeroelastic, which is my field. Actually, Kalam gave me a problem when the leaving vehicle, this is a vehicle, SLV, and it is a stand. So leaving vehicle, before the vehicle clears the length, height, because of the flexibility, the vibration, right? Vibration of the vehicle as well as of the launcher will collide with each other. This was the first problem given to me. He was completely monitoring the problem. Every day I have to meet him and show the output. Then only I can go home. At the time, bachelor, so no problem. So I used to discuss a lot of things with him. And I used to show every time the output. And it is colliding. Actually, it is colliding when the leaving vehicle, because of the vibration, these two things will collide. So that was I find out and gave it to him. And when he find out, he's come to the conclusion very immediately. He saw the output and find out if the vehicle leaves some 0.1 seconds before, it will not collide. So the vehicle is standing on a pin here. There is a pin of 50 to 60 centimeter over the vehicle is sitting down. So he reduced the pin length immediately to 40 and it went correct. So this is the way the decision was taken by Kalam. This was his mechanism. Immediately go for a testing analysis. Immediately will implement, and he decided immediately 10 centimeter he cut the pin. Still, the vehicle will be on the vehicle. So this was the first problem given by to me when I joined as he was a junior engineer in 1979. But working with him is very hard, right? So slowly we have developed SLV. We added two stop. To stop on is the thing with the first stage of SLV attached with that. It will become a SLV. We thought the height is also, so total height is almost same. Because of the stop on weight, it is there 40 tons. And payload here it is 40. And payload here is, weight is 40. Actually, it was payload was 60. But that 60 come to 40 because it was 60, 80, like that they have three versions, they were heavy. But R joined at the time, and he told me that control force was not included. So it takes 20 kg out. That's what R even now you will be knowing. R told me that they reduced to 40 because of the control force was not calculated in the calculation. So like that, lot of trial and error were there in the SLV time, but we learned the technology. We learned the technology of propulsion, solid propulsion most. And L by D, all this aeroelasticity problem, we come to understand, right? So they were slowly successful. And here one, adding a stop on to the main core, I thought it would be very easier. And we can increase the payload to 150. But this gives a lot of problem because the understanding the aerodynamics of attaching the stop on with the vehicle, the core, is given a lot of problem, because a lot of failure. I think most failure was done in ASL. We were completely knocked out every time because I was completely in charge of ASLV and PSLV, the vibration and motion and frequency. That is my part. I have to run at least 2,000 times the software to get the frequency of ASL because of the failure. So we have analyzed this way, that way, hectic. Then what happened was the aerodynamic noise created by the joint here. It has failed to hold ignition also, or like that. So then we understand how to attach a stop on with the core and the stop on. What are the effects the stop on will bring in the vehicle? And moreover, the stop ons are comparable with the core vehicle because it is also 1 meter, this is also 1 meter, and this is also 1 meter, but not in PSLV. PSLV, the stop ons are very less, very dimension. Very less dimension here. It is 2.8 is core diameter, but the stop on length and the stop on diameter is only 1. So it didn't create much problem here, but here it is comparable. It got a creative problem. We understand the stop on technology from ASL and the feedback control system also. How the flexibility of the vehicle affects, we have understand from the ASL. That's the technology. PSLV. We come to PSLV. It is the first time we are going to introduce here liquid engine. By this time, Vikas engine from France Actually, France wants some pressure transducer. We are expert in pressure transducer, so we gave pressure transducer, and instead of that, we will get that Vikas engine from the France. That's what Nambi Narayanan has gone. Nambi Narayanan and his team has gone there. It's around some 3,000 man-hours of engineers we are supposed to be given. It will be given. And the technology of Vikas, that is Vikram Sarabhai, that's called the Vikas engine. Vikas engine is nothing but the liquid engine. Second stage, L37.5. It is a 37.5 is the propellant loading of the stage. So that everywhere in the world, mostly first stage will be a liquid engine, another second stage will be a solid engine, like that. But here we have first stage is solid, liquid, liquid. So this is what the first rare combination of the, but we have the PSL. At the time, TN Station was there to write the report, PSL, to get sanctioned. TN Station also participated in this. So week 6 or 4 stop on around PSLV, it has become. So we have the payload to 1.4 tons. But remember, PSLV only launched Chandrayaan. So the 1.4 ton, and it is a polar. We are going from LEO to polar orbits. So that is the technology this changed. So here again the GSLV Mark, this is a Mark 1, 4 liquid engine again around, and GSLV Mark 3. We'll just see in details, much detail here. Right, 1 minute. Yeah. So here you can see that SLV is only 17 ton, total height is 23 meter, but payload is only 45. The payload to mass ratio is 0.27. That too in the orbiter. Low Earth orbit, 1979, first launch. After 8 years ASLV, LEO, it is total height is the same height, but payload is 150 kg. Payload mass ratio is 0.35, slightly improved. Then come to PSLV, the payload is come to 0.33 payload, but we can write higher payload 1 tons. 1 tons, more than 1 ton. It is a 93 we have. So our first flight. Then after 8 years, GSLV Mark 2. In between, Mark 1 was there. Then Mark 1 was L40 was there. Then Mark 2, where we can lift around 400. Lift of weight is 400 tons, but it can go only to 2 tons. And ratio is 0.5. Right. So like the GSLV Mark 3 is the result, which we have 630, and payload is 4.5 tons only. So it is 0.72. So here, these are the payload wise with the technology has grown. But the difference between, main difference from PSLV and because of the liquid engine, there are 2 problems has come. The technology what we have from the ASLV, which is not there in the ASLV, which was in PSLV, is first problem is 2.8 is the diameter of the PSL. Why the odd number 2.8? Why not 3? Because at the time, aluminum rolling capacity of India is not 2.8, where only the HAL. The aluminum rolling capacity was 2.8 the diameter. If we want to go higher the diameter, we want to go, but we have to, that embargo of America is there. So we could not go for that. So we fixed the diameter of the PSL is 2.8 because of the reason. Core vehicle is 2.8. Of course, with heat shield is around 4. Around 3.2. So this was at the time was a consideration. And we have 2 problems. Liquid engine. That is, liquid engine, we got BOGO and slashing. These are 2 problems, because even a SpaceX first flight was failed due to BOGO. Slashing. Slashing is the liquid slashing, the huge amount of propellant, which is in the acceleration vertical as well as lateral. Lateral will create slashing, axial will create BOGO. These 2 problems we encountered, and we have corrected it in the software, and it was more successful is PSL. Except the first launch, all other continuous there was a success. But the PSL is the workhorse now. Even Chandrayaan 1 also launched by PSL. But come to GSL. GSL Mark 2, it is again the liquid engine, and stop on is liquid instead of solid. That is a change we have done. The liquid. Here, I will tell you what happened later, the GSLV Mark 1. So this is L40. So this is a strap-on I'm telling. No strap-on, solid strap-on, and solid strap-on, same size. These are all, the first stage is same. Then GSLV Mark 3 is a L, Mark 2 is a L40. L40 means liquid strap-on, again liquid strap-on, and the go. So we got a very new technology called vented interstate in structure-wise. Vented interstate so that the burning go out, exhaust is going out instead of hitting this dome of the motor. So that way, the vented interstate was one of the structure, and we have to pass on this bulbous heat shield. Bulbous heat shield, it gives transonic aerodynamic phenomena called transonic buffeting. And all these are covered by a NACA report. How much is real, how much must be the diameter, and wherever there is a sudden change in the shape, the aerodynamic forces will be becoming greater. It creates lot of forces, and corresponding bending movement and bending movement in lower parts of the wheel. A force here will create a bending movement in all the structure. We have to design the structure for a heavy bending. So it resulted. And one important thing in GSLV is the chirogenic state. The first time we are using the main difference from PSLV to here. See, ASLV to here are propellant wise not different, only thing stop on. But ASLV to PSLV is a liquid engine, but PSLV to GSLV is chirogenic liquid. So first time we are using a cryogenic engine in the history. Lot of problems are there. I will tell you how we got the GSLV technology, because I was at the core team member signing the agreement with the last Cosmos GK with the years. I was a core team member. My main achievement in ISRO is signing that agreement with the GK for 7 cryogenic stages was given to India. I will give the story backward. So now it is the expansion again. GSLV Mark 3, heavy vehicle, high diameter, liquid propulsion. Again, the cryogenic engine developed by India. Right? This easily it clearly gives what is exactly this one. So, but GSLV Mark 3 is 4,000 kg. So India's capacity has come from 40 kg to 4,000 kg, 100 times improvement from SLV 3 to GSLV. But SSLV is different. Yeah, it was for a small people, so it cannot be compared. It can be compared with the SLV. Around some 173 kg work on this same SLV. That is for small vehicle itself. But here it is a technology orientation. This is a growth, the 4th generation. Vehicle is GSLV, 5th generation is SSLV. So 400 ton, payload mass is 4,000 kg. Correct? And this will go for geosynchronous. That is orbit wise. It is all LEO, polar, geosynchronous. So geosynchronous orbit is around, you all will know, around some 38,000 kilometers above. Polar is around 400 to 600. This is also 400 to 600. So 38,000 kilometers above with the high weight, it will need a lot of forces. Around 4 ton is there. Is a still world standard. We are low. We are not heavy lift. Where if we compare the old vehicle, we are still come. We are very less. Even see that we have done 2 hours mission and everything okay with PSLV. Mostly our achievements are with the PSLV. Under the spacecraft mission, 70 launches. In 2018 to 6 launches. So the space we have grown slowly and we are start launching for other countries. The milestone is in terms of the satellite, we can see that. Right, this is a general NASA, but our budget is very low. Comparing other NASA budget is in billion. We are in all 19.5 billion. We are in 1 billion, 1.8 billion. Comparable, and we are patents also. We have a lot of patents we've done, but still we are not up to the mark. 1.178, and is Japan and JXAS. There are a lot of patents there. Germany and even China is much more. And the revenue from I started coming from ISRO. 1 year foreign satellite, 130, the total 209 satellite we launched for other country. Right, in 1999 we started, 2017 around 133. So 209 launches we have done, and our revenue has come to in crores. to 1795, right? 201. Next to go that, the timeline of ISRO. First, it started with 1969. In Cospar. Actually, it was under Baba Atomic Center only. So the Vikram Sarabhai was taking care of both Baba Atomic and both ISRO in 1969. Then they formed in Scobar. Then Space Science Technology at Tumba is the first scientific. We are only all the activities were in the TELS. So a lot of engineers joined, all from NASA, PhD and everything. So it is transferred to SSTC, where all the people are sitting. I was also sitting. And once Kalam also sitting in the opposite room. Sivadananda Pillai is in the front of Kalam room. After seeing Sivadananda Pillai only, you can see Kalam. He was sitting in the opposite room. I used to see that. So in 67, all the site experiment was the first one. Then the village is covered by a television. Site experiment, it's called satellite telecommunication of earth stations in Ahmedabad. Then only the television era is started. So this is a remote 1976, 76, all our site. But only thing 1979, we were first SLV3 was. But in August 19, it was a first stage was functioning okay. But second stage, because of there was a controversy, but because of some particle, some valve didn't close, the butterfly valve didn't close. For the control field completely depleted. So there is no control for the second stage, it is failed. So 1979, Kalam was a project manager. Then it is 1980, it was a success. Kalam was a project manager. And 1984, third SLV launch, Kalam was not project director. He was in the VIP gallery. Fourth SLV, he was in DRDO. He didn't come for launch at all. So in SAT, so one by one we started all the operational satellite side, not vehicle side, but vehicle is only PSL. Then slowly experimental GSLV start coming. So the RLBDD is one of the demonstration. So re-entry launch vehicle. Launch vehicle go to reusable launch vehicle has to become. So like our Elon Musk introduced the concept of re-entry reusable launch vehicle. Maybe the stages can be reused. Like a aircraft is reused again and again for their fleet. So rocket also we can do that. So that was the reusable launch vehicle. That also under demonstration, not at float still. Still we are doing that. That the technology has to be come back. Then next round is this scramjet. Scramjet is like igniting, as Dr. Sivan used to tell. It is like igniting a matchstick in a cyclone. So in a high speed, you have to ignite a engine, ram engine. That so that a ram engine, that technology also being now developed. Right. So these are the technology heights. We come as this one. And a bullock cart, I will tell you, this is not a bullock cart. India is not poor, that much poor to use a bullock cart. People will be telling India is taking the satellite in bullock cart. Bullock cart will be wantonly taken. We are non-electromagnetic interface is a wood. So for that only we were the test, it was taken. It was Apple, the project director R Elangovan. He told me we paid 150 for this bullock cart over for the test. So that is the reason why we use the bullock cart. It's not by we are poor or anything. So 96, but satellite wise, 1969 is Apple, and then our Aryabhatta, Bhaskara and everything. But the launch vehicle we have achieved only in 1980. Right. So that is the technology progression of launch vehicle is first is the sounding rocket vehicle. The closed loop and strap-on technology, we approved that in ASLV. Bust basics. SLV is like what Kalam used to tell. I have launched only a pencil type. Now people are using very large vehicle like that. So this was the first vehicle where we land all the guidance, propulsion, structures, avionics, everything. It can work like that. But ASLV, strap-on technology and closed loop. And it is again liquid engine, their problem. Cryogenic engine, problem. Again, cryogenic engine. So these are this one. These are the milestone. So we have the PSLV as a workhorse. Used to take Sivan used to take it is a naughty boy, and GSLV Mark III is a fat boy. This is where we stand now. So ISRO also expanded throughout. It is not in the church now. It started in the church, but throughout India it is there. And now the structure also slightly changed. We have Antrix, we have NSIL in space, and ISRO also. So we can do open to the people who are interested, startups and everything. We can use the ISRO facility is a boon. It's open up this current government, right? And interestingly, I want to say, tell this is a PSLV configuration. What is to look inside, liquid tanks and everything. DTO and the sun synchronous payload at put 1.70. This was the first stage where S139S stands for solid, 139 is a propellant weight. Again, 6S9 means stop arms. S is again solid, 9 is the propellant weight, 9 tons. The second stage is 40. Is a liquid engine, 4th stage is a solid, and again, here will be the heat shield, inside will be the sand. It is a payload. That's what we used to define. This is a general configuration of the vehicle. Total number we had to close this, set the world's record also. And the differences also you can see that in the GSLV and PSLV. And again, the PSLV configuration, 4L. 4L means this was the GSLV Mark 1. 4L40 liquid engine, S125 is the core first stage solid, and L37 by the second stage. C12 was the cryogenic. This was the addition. The C12 actually story behind the denial of aerodynamic tech to India, I will tell you, for your confidentially, not for open. So there was a Senate member in America when we are trying to get cryogenic technology from Russia, last Cosmos decade. And it was vehemently objected by America. So they told you should not give cryogenic technology to India. But Russia was suffering, it is disintegrating, suffering, starving, lot of starving and everything there. They are in need of food and everything. So at the time I was looking the GSLV core team member. So so Russia is ready to give the technology for a cheaper price because they want money. For 7 crores, I think seven cryogenic stage we got at a very cheaper price. But one senator at Russia American Parliament, he was very, because at the time America was giving aid to Russia. It is around in billion. 325 billion is more or 7 crore is more, or like that he was asking. And technology transfer should not be there. We will just do the state, they have to use it. Indian has to find out the technology. Like that it was 7 stages of that. The senator is nothing but Joe Biden, who is the president now. And we have launched Yeltsin packet technology transfer to India abroad. And we have launched for US only more satellite. This is what the achievement of India. So the person who objected here, you can see that. So US only we have launched the US, a person who don't go and give the cryogenic technology has now approved and giving satellites to launch. This is the achievement of India, right? Then we developed taking that, we developed our own cryogenic technology. We have tested that C20. What we are now using is Indian cryogenic technology rocket engine, not from Russia. So this was achievement. This is the C20 cryogenic is the latest achievement in our VSSC, which is denied one with all this vendor interstage and everything. So Mark 3 is the highest level. Okay, can I stop here? Yeah, they have something here also. So you can see that United States only we launched 139 satellite for them. Right? Then we done the recovery experiment. We'll send the capsule and it will land, and so that we can recover the payload from the sea. This is one of the space capsule recovery mission was also done. But in this, the heavy means it must be above, the payload must be around 21 tons. Area and payload, you see that 21 tons. And payload of Falcon is also 22. So like that, we have to reach this, how to reach this kind of capacity. The payload has to be increased. Payload has to be increased only if we tried a lot of vehicles. So payload has to be increased only by, and another one I want to tell, this is not by first rocket launch, it is on 21 November 1963, it is not 72. Actually, we are not poor. At the same time, Indira Gandhi is celebrating Rajiv Gandhi's birthday in the flight when we are taking the satellite in the cart. Okay, and then it is not so we are poor. So what we have to do now is we are going to United Launch Vehicle, right? This launch vehicle, where it was 4 tons, now we have to go to 6.2 tons to space. The United Launch Vehicle is called. 2S200 is solid propellant, 200 tons propellant. S is semi-cryogenic. Now, after cryogenic, the term comes in semi-cryogenic engine 160 ton, and C30 is a cryogenic. So this is the configuration we are going for further ahead. The semi-cryogenic engine has to be included. Then only we can increase from 4 ton to 6.2 tons. Right, the payload has to increase, whatever the technology, then it is not this one. Okay, whatever is on, that is one thing we have to be in mind. When only you can see that if you compare with the vehicle, you can see that it is only 8 tons, not at reach GSLV, but Falcon, SpaceX reached around 22 tons, 63 tons, 21 tons again area on ESA, and Delta Heavy 28 tons, and Space Shuttle, which is now retired, is 27 tons. We have to come to the double-digit payload, double-digit tons payload, then only we have reached the technology. We all other worldwide, they are 8 kg, because if we got 4 kg constant, we must have taken that UAE order. UAE has launched their satellite taking to Japan. Instead of that, India must have got that order and launched it for UAE. Okay, so that's why it's a lot of way to go. Still, we are in semi-cryogenic engine. So our payload is just touching 8 kg, 8 ton. It must go to double digit, like a 10, 12, 14, like that. Then only the feature, we have to go. Lot of things like International Indian Space Station is there, Gaganyaan is there. Men's orbital is there. Even though it is 60 years back, a man has orbited the Earth. Gaganyaan is going to orbit the Earth for at least a week with 3 people. There is a record. Others are gone, one man only gone by 1 orbit. US also like that. Alan Shepard suborbital, and John Klein is a 3 orbits. And China also orbit only, but India is going to do it in a bigger way. 7. They have to be in space for 7 days, and 3 people are going in the first orbit flight itself. So all the human space flight is coming up. The technology has to grow forward. Thank you. Any doubt? Any doubt?
Anybody for questions? You got.
Sir, good evening, sir.
Good evening.
Sir, one clarification.
Yeah.
Sir, now we are using that cryogenic engine.
Yeah.
So, in which stage we are using, sir?
Third stage.
Third stage. So we have to maintain that the temperature as per the norms.
Yeah, right. Soaring and all the associated problems. These are block always cryogenic. You can easily.
Suppose if you are going for higher altitude, so the temperature will increase.
No. See, altitude is not there. Yeah, rocket altitude maximum is around some 250 kilometers. Any rocket. Okay. The altitude maximum 250 to 300 kilometers. So it will release the satellite, either GSLV or PSLV or SLV. They will reach around 250 to 300 kilometers. They will release the satellite from there.
Okay.
That is the thing. So the temperature variation is already known. So whatever the vehicle, but only thing, the difference is the payload weight, 40 kg SLV and 4 ton GSLV. But the height, altitude, or more the releasing altitude, I mean the satellite injection will be the same.
Okay. Thank you, sir.
Any more questions? Dr. Professor Elangovan, sir, it's very nice talk actually. Various types of propulsion, and then our years growth of our ISRO, and now it is going very fast in the technological development in this digital world. Actually, I think we will reach. What is your ambition? Was that higher capacity launch vehicles? Definitely, I think now that the young people are there in ISRO, I think they will do the wonders for our in India nation. I hope your dream also will come true.
Okay.
Actually speaking, sir, I am also from Trichy. I studied in National College in 1962-63.
Is it? Okay. I am
And
1970.
Yeah, I was 62, 63 batch. At 66, I was in St. Joseph's, my BSc physics. And then I joined Nagaraj Engineering. So that is my history in Trichinopoli also. I was from school days onwards, I was in Trichy.
Okay. I will talk to you later.
Yeah, we will definitely talk, sir. And I think Gokul, are you there?
Sir, yes, sir.
Yeah, please. Now we ask the questions are there, then you can tell our Sivaraju a word of thanks.
Definitely, sir. I think students, anybody is having any questions, I think
now you can
unmute yourself.
Fatima Naval.
They can unmute and they can ask the query, sir.
There was a good strength, about more than 50 people have attended. Nice.
Yeah.
Yes.
Yes, sir. I think having somebody is posting, I think, sir. I think Fatima Hanal, you can unmute, ma. Otherwise, madam, you can give them
Hello.
Yeah.
Hello.
Hello. Yeah.
Hello,
Yeah.
sir.
Ask. Yeah. Tell me. Ask.
Are you hearing?
You are not audible. Fatma, ma'am. Gokul, you asked her to put this thing afterwards by call now. You are not able to hear her. Just ask Gokul. Shivraj, you can tell word of thanks now.
Okay, sir. Okay, sir. Good day to all of you, sir. At the outset, sincere to our today's guest and speaker, Professor R Elangovan, for ISRO scientist and core team member of GSLV M1 under the topic SLV to SSLV journey of ISRO. For valued information in this event for benefit of our fellow engineers, I express my gratitude on behalf of everyone. Engineer S. Kannan sir, Chairman TNSC, Engineer D. Gokul, Joint Secretary, Dr. K. Vijayaraja, Committee Member, Aerospace, Council Members, Committee Members, Chairmen of all local centers, and members and special invitees and students of the various colleges. I thank each and every one of you for being here and making this event a grand success. Thanks again. Jai Hind, sir.
Thank you. Thank you very much.
Thank you. Thank you.
Thank you. Thank you all for giving the opportunity. Thank you.
Thank you, sir. Thank you very much.
Right. Thank you, sir.
Radhi, you can close this
Thank
thing.
you very much, sir.
Thank you. Thank you very much.
Okay, sir.
Yeah.